Hello students. So this is lecture number 14 and we will solve here the solution of homework number 1. Okay. Okay. So uh, in this homework actually everybody got different set of problems, the same problem but different data in that, different numbers. So it's not possible to exactly solve the problem, to exactly get the number that you should have written, so because for every student that number will be different. Hence I'm going to solve symbolically and you can put your data there and you can get your numbers. Okay. So first problem was something like this. First problem means four problems. Let's say question number 1 to 4, let's call. For you it will be probably different numbers, but still I am calling it question number 1 to 4 just for reference. And the question was something like this. So there is a wall here, yeah, and hinge here. So one is like this, another is like this. Again here it is a pin joint or hinge, and this is a force F3 x here, and this is F3y. Okay, and also given this is a node number 1, this node number 3, node number 2. Okay, specifically the question in for all of you, this theta, this is theta 1 which will vary, and theta 2 be equal to 0. Okay, so this is the setup. The question that being asked is if displacement here is u 3x and upward is u 3y, then how will you calculate? Means if you say u 3x u 3y is equal to a b c d, and then you have f 3x f 3y, then what is the value of, right, what is a b c d? And question number 1 will ask a, question number 2 will ask b and c and d, hence 4 questions. So this is what the question were. Okay, now the how will you solve it? So solving it, first we have to find out basically the force vector, yeah, and the displacement vector. So displacement vector, so because this is a truss problem, you have node 1 to 3, and hence you will have 3 times 2 6 by 6 the stiffness matrix, 6 by 1 will be the force vector, and u will be, we can say u will be equal to here both will be 0, right. So both degree of freedom u1 and u2 both will be 0, so you will have 0 comma 0. Similarly for this is 0, this is 0, both of them 0, so we have 0 and 0, and this one we don't know what that is, yeah, but we are saying this is u3x, this is u3y, so we will write comma u3x comma u3y. Okay, so this is what u is. Okay, similar transpose of that. Okay, similarly the force vector F will be given by, since displacement is 0 here, which is given, force we don't know what that is, you may say this is there will be some reaction, yeah, so there may be some reaction we can write it that way also. So there will be reaction like this one and this, right, and this will be f1x, f1y, f2x, f2y, right. Okay. So we can write here accordingly. This will be either we can write it will be f1x comma f1y comma f2x comma f2y comma, now we have this and this as well. So accordingly will be f3x comma f3y. Yeah, this is so transpose. Okay. Now stiffness matrix. Okay, so what we see here, like whatever the stiffness matrix is, we will write finally Ku equal to F, and U is given by this. So what you see is U here will be 0, 0, 0, 0. So 4 of them, initial 4 rows will have zeros in U. Yeah, so only the 5th and 6th is non-zero. So finally, when we are going to write some different, we can also write this one as after taking into account zeros here, we can write only 4 members of k, or 2 by 2 of k multiplied by u3x u3y is equal to f3x f3y, right. So since you are going to ignore the first 4 rows, finally you will have one k, instead of having the whole thing you will have here u just these 2, and in f also you will have just these ones, and k you will have only the stiffness corresponding to this is 1, 2, 3, 4, 5, 6, so only corresponding to 5th and 6th rows and 5th and 6th columns only. Yeah. So accordingly, we don't have to write and assemble like that. We know that that is the case. Only 5th and 6th rows will be taken into account, or simply the 2 rows from here, 2 rows from for this one both added together, because both of them are contributing, and that will be our k. So this way, that way it can be shortcut to solve that way. Okay. So accordingly we can say that let's write as k dash, yeah, k dash times you have u 3x u3y is equal to f3x f3y, where k dash is equal to, okay, what. So this we have to find out, right. So we can say this is equal to k dash 1 plus k dash 2, right, and k dash 1 will be equal to, so let's see, for this one you will see that it has 1, 2, 3, 4, right, 1, 2, 3, 4. Now the here this is 1 and 3 will have non-zero entries, otherwise data corresponding to degree of freedom 2 and 4 will have zeros. Okay. So what we will get, this we will get simply like this. So 3, 4 we are talking about, right. So if you just, we can write, this will be, if you write here, okay, so first we have to also find out the values. If this is L, for you the L given for this one, right. Okay. So for this one you will find this is L and this is also theta. The L cos theta will be this one, so this will be L cos theta. Yeah. So length of this is known, A and A EA is also is given. Yeah. So we will use that. So what we get? We get only EA over L corresponding to this point only. So we can write it as, so that's 3 and 4. So 4 will be all 0 entries. So we can because 4 is upward direction, so right. So 4 will be a 0 entry. Also in 3 we will have here we will have 1 like E A over L cos theta, yeah, and we can also work out this way. For a bar like this one, and where you have 1, this is 2, this is 3, this is 4, the EA and the length is, let's call small l, then you know that K E will be equal to EA over L, right. And 4 by 4 format, if you see, so then this will be 1 0 minus 1 0 0 0 0 0 minus 1 0 1 0, right, then 0 0 0 0, that's what that is, yeah. So where this becomes 1, this becomes, so right, so this becomes 1, this 2 3 4, similarly this becomes 1 2 3 and 4. So only if you are interested in 3 and 4, right, only 3 and 4, so we are interested in this only this. So 1 0 0 1, that's it, nothing else is coming, yeah. So hence that's what we can write here. We will get 1 0 and EA over L, a small l, but in this case a small l is equal to L cos theta, so hence we have that. So this we get because of the second, so the element number is also given. So this is element number 1, this is element number 2, okay. Now element number 2, this is this element number 2 basically, yeah. So but 2, maybe we write 2, this was 2 basically, okay. So element number 1 will have what, is equal to what? Similar kind of thing we can do. Now we have to write it for the one which is slant like this, and we have theta like this one, right. And whatever we get, we have to, so we will have again in this case we will have 4 entries. The stiffness matrix will have, for the element will have 1 2 3 4 5 6 7 8, so total 16 entry, and we are interested in the last 4, the way we did here, yeah. It is the same thing here, right. Here we are interested in only last 4 because that's what K dash is, yeah, okay. So we are interested in the last, so this is a shortcut basically, we are trying to not assemble everything, we just take whatever is needed so that we can solve it fast. So if you remember that if some element is inclined like this one, the last 4 will be what, yeah. So we can you can say that, see here it will be cos square theta, cos theta sin theta, minus cos square theta, cos theta sin theta, right, like this one, sorry, cos square cos theta sin theta minus cos square minus cos theta sin theta. Similarly here this will be the, so whatever the value is here, I mean we are going to repeat like this one, yeah, because it has to be symmetric, and so on. You will see basically here this will be cos square theta. So, you will see here cos square theta, sin square theta, then cos square theta again, sin square theta. So, this will be cos square theta, this will be sin square theta. Okay, so we can write like this, EA over L, right, and then you will have cos square theta. So, cos square theta will be here because cos square theta, sin square theta, cos square theta, sin square theta, and this will be sin square theta here, okay, and here you will have sin theta cos theta, okay, and here and here you will have similarly sin theta cos theta only. And you know that this is not just theta, this is theta 1 basically. So, accordingly we can write this is theta 1, theta 1, theta 1, theta 1, because theta 2 equal to 0. So, all sin theta 1 only. Okay, so then k dash will be nothing but we are going to add them together, right. So, k dash will be equal to k1 dash, k2 dash, we are adding them together and accordingly we can write, yeah. So, k dash, k1 dash plus k2 dash is equal to EA over L and 1 over cos theta 1 plus this and then this, yeah. So, we will have 1 cos square theta first. So, we can write cos square theta plus 1 over cos theta, then we have sin theta cos theta, then sin theta cos theta, then sin square theta. Okay, we have that. Again, all are theta 1, so let us write theta 1 only, okay, and the value of theta 1 is given. For everybody it may be different, okay. So, this is what the k dash is. So, the final equation we will write it as u 3x u 3y is equal to L over EA. This will be inverted, you are going to invert it and multiplied by, okay. So, what is the equation? Our equation is k dash times u 3x u 3y is equal to f 3x f 3y, right. This is what that is. Hence, k dash hence u 3x u 3y is equal to k dash inverse multiplied by this. So, k dash inverse is nothing but L over 3a to begin with multiplied by the, we are going to invert this matrix. So, this will be simply sin square theta minus sin theta cos theta minus sin theta cos theta and then cos square theta 1 plus 1 over cos theta, okay, multiplied by f 3x f 3y, okay. Okay, now here we have theta 1, theta 1, theta 1, theta 1, theta 1 only, okay, like this, okay. So, and we have to divide it by, and we have to divide it by the determinant of the original, this one. You can see that if you multiply, determinant of that will be this multiplied by this minus this multiplied by this. But if you see here sin square theta 1 and cos square theta 1, will make it sin square theta 1 cos square theta 1. Similarly, this times this will make it sin square theta 1 cos square theta 1, right. So that will cancel. So this multiplied by this will be cancelled by this multiplied by this. So what you will have remaining is just sin square theta 1 divided by cos square theta 1. That's it. So your answer here, determinant is nothing but simply sin square theta 1 divided by cos theta 1. Okay, sin square theta 1 divided by cos theta 1. Okay. Okay, done. So here you will see your answer coming. Basically, the accordingly you can find next thing will be simplify. So u3x, okay, and then u3y is equal to, and then you will have L over L over 3a okay multiplied by not 3a but Ea. So L over Ea, okay. So L over Ea, then you have cos theta 1 divided by sin square theta, cos theta 1 over sin square theta 1, and then you have sin square theta 1, sin square theta 1, then you have minus sin theta 1 cos theta 1 minus sin theta 1 cos theta 1, and then cos square theta 1 over cos theta 1, cos square theta 1 plus 1 over cos theta 1. That's it. And multiplied by, here we are going to multiply. Okay, so there only let's multiply. So let's write like this, and we are going to multiply it by f3x f3y. Okay, hence we can write down here a will be equal to, right. So a will be equal to L over Ea cos theta 1 over sin square theta 1 multiplied by sin square theta 1 will be simply L cos theta 1 over Ea. This will be A. B will be equal to, okay, minus L over Ea cos theta 1 sin square theta 1, okay, then sin theta 1 cos theta 1. So what we will see here is one sign will be gone. So cos square theta divided by sin theta. So minus L over Ea cos square theta 1 over sin theta 1. Okay, is done. And you know that actually B and C will be the same, right. So basically the C will be the same as B, D will be equal to minus L over Ea cos square theta 1 over sin theta, okay, and D will be equal to this value, this multiplied by this one. Hence we have L over Ea cos theta 1 divided by sin square theta 1 okay, then multiplied by cos square theta 1 plus 1 over cos theta 1 is equal to, yeah, simplification will be not much. So, we can write L over E A and then cos cube theta 1 plus 1, yeah, and divided by sin square theta 1. So, this is what the D will be. So, you can find out A, B, C, D like this. So, this answers question number 1 to 4. Now, we will solve question numbers 5, 6, 7. Okay, so 5 to 7, which is based on the 4 springs in series. So, something like this. Okay, so we have U1 R1, U2 R2 and U3 R3, and 3K here, 2K, 3K and 2K. Okay. K value is given for everybody. Okay, so we have to find out the value of R1, R2, R3. So, given K value is given by this K, basically talking about this K only. Okay, so let us write it as small k. Okay, so this is actually all a small k only. Okay. Okay, so a small k is given and also given U1, U2 and U3, and you have to find R1, R2, R3. Okay, so 3 things to be found and you have 3 questions, corresponding questions. Okay. Okay. So, how to find this one? Actually very easy. So, you have to construct the, you know that you start with U and then you will realize that which all rows you have to keep. So, you start with the displacement vector and you get, this is 1, 2, 3, 4, 5. So, displacement will be 0, U1, U2, U3, then 0 again, right. So, you will have 0 comma U1, U2, U3, right, and 0. And similarly, force will be equal to, you will have some reaction here, right, some reaction, you can call it this, anything you can say, let us call it F1 and this is F2, you can say, no problem. So, you can write F1, then you have R1, R2, R3 and then F2. Yeah. Okay. So, where we have, let us say here F1 is there, similarly here F2 is there. Yeah. Okay. Again this is also transpose. So, you notice that only 3 rows will be required to calculate the values of R1, R2, R3. So, again we will have the full K U equal to F, and where K will be 5 by 5, U is 5 by 1, F equal to 5 by 1. This can be since U has only 3 non-zero entries. So, we can also write k dash u dash equal to f dash, where u dash equal to nothing but u1, u2, u3 transpose, and f dash equal to r1, r2, r3 transpose. Yeah. So basically r equal to these values, if you want to find out, we just multiply k dash to u dash, where u dash is known. Basically we just have to find out k dash, and k dash corresponds to only to these nodes only. So we find out what is the stiffness matrix at this node, and due to this one what is on this node, and so on, so that's what we have to do. Okay. So you can also make the big K, if it is convenient, you can make like this. Big K will be equal to a small k here, and then this will be simply 3, this will be 3 minus 3 minus 3 minus 3 3 multiplied by k. This will be 2k 1 minus 1 minus 1 1. This will be 3k 1 minus 1 minus 1 1, but at different points. Yeah, so accordingly we have to see, right? So this k we have taken out, first one is 3k, so we will have 1 3 minus 3 minus 3 3, it will be plus 2 minus 2 minus 2 2 plus 3 minus 3 minus 3 3, right? So we have 3k first, then 2k, then 3k, then 2k again. So plus 2 minus 2 minus 2 2. So this is what it will be. Rest will be 0. So we have to see just the middle one only, right? So rest will be 0, so you can write here 0 0 0 0 0 0, similarly here 0 0 0, then 0 0 and 0. And what we don't want is the first one and last one. So our k dash will be simply this one. Okay, 3 by, instead of 5 by 5 we will have 3 by 3. So this is k dash. So okay, this is k dash. Okay, so our values, the now equation becomes simply here k dash will be equal to k, and we have 5 minus 2 0 minus 2 5 minus 3 0 minus 3 5. Yeah. So this is what our k dash is, and hence we can use f dash is equal to k dash times u dash, hence r1 r2 r3 is equal to k dash. K dash is 5 minus 2 0, 5 minus 2 0, then minus 2 5 minus 3, minus 2 5 minus 3, and then 0 minus 3 5, 0 minus 3 5. Okay, and multiplied by you have u1 u2 u3. Hence you can very easily you can find out now. So r1 equal to this multiplied by this, r2 equal to this multiplied by this, r3 equal to this multiplied by this. Yeah, and hence you can find out r1 is equal to 5 u1 minus 2 u2, r2 is equal to minus 2 u1 plus 5 u2 minus 3 u2 u3. Okay, r3 will be equal to minus 3 u2 plus 5 u3. Yeah. So, these are the answer, where since u1, u2, u3 are given, you can exactly find out value of r1, r2, r3. Now, the next question is question number 8 to 10, and this is for the electrical circuits given, and circuit is like this one. So, we have R here, 2R, this is 3R, this is E given here, and we have this another electric cell here. So, this is like this, okay, this is the E here also. Okay. So, if you want to solve it through finite element analysis, first thing you have to do, you have to number the nodes, right. So, nodes you have to see which all first you have to know which all things are the elements, right. So, elements, you know that resistances are the elements. So, this is how many elements are there? 1, 2, 3, there are 3 elements only. So, elements are resistance only in electrical circuit. Element is resistance. So, number of elements equal to 3. Hence, only those point which is attached to the ends of the resistance will constitute the node. So, number of nodes will be equal to, if you see this one, you have this point and this point, right. If you see this one, this point and this point. So, this and this will have the same potential, right. So, this will constitute one node. So, you will call it node number 1. Okay. Similarly, if you see here the second one, the second end of R1 is here. Okay. So, the second end of 2R is here, both are combined basically. So, hence this whole thing will constitute node number 2. Yeah. So, you can, this is node number 2. Okay. So, both are accounted for now. Number 3, one end is at 2, the other end will be at the 3. So, we have the 3 here. Okay. All others will just provide the potential. Yeah. So, this is providing a E is providing a potential difference between this point and this point. Similarly, this cell is applying potential difference between this and this point and this point. Yeah. So, that is all. Now, cell is given, and actually it is not given that potential here is 0, you know. So, and I am not asking what is the potential here or here or here. The question has what is the current flowing through R or 2R or 3R or E, and as you know that current depends on the potential difference rather than absolute potentials. Okay. So, you can assume here is to be 0 possible, or you can also have A, then here it will be A plus E, and then here it will be A plus 2E. You can also do like this one. But if you have A equal to 0 here, it makes life easier, you know, so it makes life much easier. So, accordingly, we can take here B equal to 0, and hence B at here at this node. Okay, so B will be 0, we are assuming, right, assume this is not going to change anything. you can also assume B equal to A also. Then B here will be A plus E. Here it will be A plus 2E. But if you assume this 0 here, you will have here the potential here, you will have E. So, just write like B equal to E, and here it will be at this end it will be B equal to 2E. Yeah. Why? Because it is a 0 here, so because of that E will be here. Now E is here, this is going to add E more, so 2E here. So here 2E, here 0. Actually it's easy without solving through the finite element analysis. You can see that here you have 2E, here you have 0, hence the current will be equal to 2E divided by R through this one. Similarly, for this will be 2E divided by 2R, hence E over R. So, you can actually find out very easily, but the idea here is to solve through the finite element analysis. Okay, and all the question was very easy. You can actually solve very easily based on the things you learn in class 9, 10, you know. But still here also if you see this is 0 here, so 0 here, and this is E here, right. So, here 0 and here E. So, potential difference will be E 0 and E, to E divided by 3R, right, E over 3R, and you know here the potential is more here. So, current will flow from higher potentials to lower potentials. So, current will be flowing like this one, like this. Excuse me. On the other hand, if you see here B equal to 0 and B equal to E, so current will be flowing left to right. In this case also 2E here, 0 here, so left to right. So, you see left to right, you have right to left. Okay. Okay. Okay, now we are going to solve the finite element analysis, and we found out that we have the 1, 2 and 3 nodes. So, number of nodes will be 3. This is the one of the questions, right. So, say number 8 we have solved. Yeah. So, number of nodes you will take as 3, here 1, here 2, here 3, that is it. Okay, so you can have now U vector accordingly. So, U will be equal to, will have 3 rows and U will have potential. So, if you have a node number 1, so potential will be 2E, so you write 2E. Node number 2, potential is 0, so you write 0. Node number 3, potential is E, so you write E. So, we are done with U. Okay. Now, F, what is F? Do we know F? F basically tells you what is coming to node 1. So, coming from what? Coming from the external cell. So, the cell is external to the circuit. Okay. So, your circuit is basically equivalent to something like this. You have okay. So, this is what your circuit will look like. So, you have a node, or we can actually further simplify. This is R, this is 2R, this is 3R, and current will be coming. This is what the positive current, right. So, you have the current coming like this one, current coming to this node 1, current coming to node 2, yeah, okay, and current coming to node 3. So this is node 3, yeah, node 3. So you can also draw the same thing differently. So you can have like this. Okay, so you have R, let us say, then you have second resistance, okay, the second one. So this R, this is 2R, and then you have current which is coming to this one, and this you will call, this is number 1, so you will call the I1. Then this is number 2, to this also there is some current coming, this will be I2, and then from okay, this is number 2 here, okay, and then from here you have another one, go like this, yeah, and this is 3R and this is I3. So this is how, if you look at that, see, this is node number 1, this is node number 2, this is node number 3, yeah, so node number 3 here, yeah. So this actually we have to solve, right. So we can write I will be I1, I2 and I3. I1 will indicate, we can write what is I1? I1 is this, okay. Now I2 will be the whatever current is being is coming to this node, total, which is coming from the outside, yeah, coming from the outside. And if you see here, this is internal structure, this is also internal, this is also internal. So at this all internal, only thing which is, this is cell is outside. So basically what is this current is the only thing which are what the meaning is. So this current will be I2. Similarly the I3 will be in this case whatever coming to point 3, yeah. So the point 3 here to this one, okay, the meaning is it has to come to this circuit, to this resistance, this one, because this is also external, this is also external. So we don't care what is coming to this one, what is coming to this one, what we want is what is coming to this only. So this is I3, so this is I3, and this is a positive sense. The one which is entry coming towards the node is positive, so hence this coming towards the node is positive, this coming towards the node is positive, this coming towards the node is positive. So hence we have like this. Any value, if I get a negative minus sign, that really means current is not flowing like this one, rather it is flowing like this, yeah, and so on, okay. Yeah, so now we can find out what is the stiffness matrix. The stiffness matrix will be, you have 1 here, so between 1 and 2, this also connected between 1 and 2, right, and this is connected between 2 and 3. So you get 1 over R because of this. So you will have 1 over R minus 1 over R minus 1 over R 1 over R. For this one it will be 1 over 2R minus 1 over 2R minus 1 over 2R 1 over 2R, and for this one will be 1 over 3R minus 1 over 3R minus 1 over 3R 1 over 3R, right. So this is and we combine them together. So basically we will get a 3 by 3 matrix, and the K will look like accordingly. K will be equal to 1 over R. So first this one, yes, between 1 and 2. So 1 over R plus 1 over R. Maybe we put this in common because 1 over R will come. Okay, so 1 over r multiplied by the first one will have r only, so 1 minus 1 minus 1 1 done. Second will have 1 over 2r, so that means 1 over r multiplied by 1 over 2, so we will have same thing plus 1 over 2 minus 1 over 2 minus 1 over 2 and plus 1 over 2, because both of them are connected between 1 and 2 only, hence they will just add to each other. From 2 to 3 we have 3r, 2 to 3, so okay, so 2 to 3 is here, this is 2 3 2 3, so here we will get 1 over 3 minus 1 over 3 minus 1 over 3 1 over 3 like this, and here it will be 0 and 0. Yeah, so equal to 1 over r, and we get 3 over 2 minus 3 over 2 0 minus 3 over 2, and here we get equal to 6 here, and then we get 6 plus 6 plus 3 plus 2 11, right. Okay, 11 over 6, so we get 11 over 6. Okay, and then after that we get minus 1 over 3, similarly 0 minus 1 over 3 1 over 3, this way get. Okay, so done. Okay, now k is we have to find out what? We have to find out I, and I we know that f is basically I, right. So this is f means I1, I2, I3 is equal to this, have this multiplied by the u, right. So 2E0E, so we can write k first, so k will be equal to these things, 3 over 1 over r first, so write 1 over r, then 1 over 3 sorry 3 over 2, so okay, correction, 3 over 2 minus 3 over 2 minus 3 over 2 0 okay, so minus 3 over 2 11 over 6. Okay, so we can have make it symmetric, so we go minus 3 over 2 0, so we have 11 over 6 here, and minus 1 over 3, so minus 1 over 3 minus 1 over 3 and then 1 over 3 here. Yeah. Okay, and multiplied by we have E multiplied by u, right. U have we 2E0E, so 2E0 and E. Hence we can find out I1 is equal to, see here, this multiplies by this one, 0 with this and 0 with this, so 0 it becomes 0, this becomes 0, this becomes 2E multiplied by 2E multiplied by 3 over 2, so 3E over R, so I1 is 3E over R, right, so 3E over R. Yeah. So 2 cancels out, so 3E over R is I1. Okay, get that. I2 is will be equal to, if you see here, I2 will be equal to this multiplied by this one. So, we have 0 here multiplied to this one. So, we have this or minus, and then we have like this, so all minus. So, we get 2 cancels out, so minus 3e. So, minus 3e and then minus e over 3. So, minus 3e minus e over 3, of course divided by r. So, divided by r, yeah. So, this becomes equal to minus 10 e over r. Okay. Okay, done. Now, I3 and we have this multiplied by this. So, this to 0 0, this multiplied by 0, this multiplied by 0 is 0. So, we have just e over 3, simply e over 3. So, I3 equal to e over 3. Okay. So, we got the displacements, and that really means the in the circuits we like I1, this I1 we found out, and the values are like this. So, let us draw the circuit here only, and we will understand what is the meaning of that. So, we had a 1 R here, okay, and then after that 2 R is like this, both joined. So, this is R, 2 R, and this is the I1. Yeah, and then this is attached to battery source, and we call this is I2, and we have another resistance here 3R, and we call the current coming to this is I3. Yeah. Okay, and we found out what? This is I1, which is equal to 3 E over R. This I2 equal to minus 10 E over R, and I3 is equal to E over 3. Okay. Okay. So, this tells you many things. One thing is we have in yellow I am going to also draw the external cell, and cell here was looked like something like this, yeah, and this is connected to like this, and second cell was here like this, and this is connected like this one. So, looking at it, we can also find how the so let's write E and E here. So, we can find out how which all which are the currents which are flowing this one. Yeah. So, the questions are, what is the current flowing through R and 2R and 3R. So, this is 3R, and the upper cell means this one and lower cell. So, looking at this one, you know that current flowing through the upper cell is nothing but I2 only, but here we indicated this to be right to left, but we got negative. Hence, current flowing through this cell is from left to right, and value is 10 E over R. So, we can write that. Okay. So, and similarly here also, here current flowing through this is nothing but the whatever we get that. So, whatever current is coming to this one should come from outside, and outside source outside of this circuit is the cell basically, and hence the cell will provide this much current. Yeah. Okay. So, this the current will be flowing through this lower cell will be 3 over R. So, we can write current flowing through lower cell equal to 3 E over R. Okay. Okay. Similarly, the current flowing through the upper cell will be equal to this 10 E over R. And this will be left to right, because actually it is negative when we call the value is negative, but the positive current is from right to left. So, that means it is going left to right. So, left to right. In this case 3 over R, and this is flowing through, this one the sense is correct. So, this is flowing right to left, so right to left is correct. So, here we can write right to left. Okay. So, this is right to left. So, thus for external cells we have found out what is the value is and what is the direction. Now, through this one, through 3R is nothing equal to, this is the value of I3, value of I3 is the current flowing through 3R, right. So, this will be E over 3, R term will also be there. Okay. So, current flowing through 3R, you can say current flowing through the upper cell equal to I2 equal to I1 equal to I1 equal to I1 equal to this one. The current flowing through the current flowing through the upper cell is I2. Okay, so this should be I2. So, we say minus I2, let us write minus I2. Why minus I2? So that we have positive term, and hence we write like this one. Okay, left to right. So, left to right. Okay. So, here current flowing through the lower cell equal to, so basically this is equal to I1 only. Yeah. Okay. I3 will tell you the what is the current flowing through 3R. So, the current flowing through R3 or 3R equal to I3 equal to, what is the value we get? We get I3 is equal to E over 3R. So, E over 3R, and the value is, as our positive value was from right to left, and we get the positive value, hence it will be like this one only. So, right to left. Okay. Now, to find out the current flowing through individual resistances like R and 2R, we have to write individual equation for the element. So, that really means we have to write 1 over R minus 1 over R minus 1 over R, that will be the distribution matrix, multiplied by, you have V1 and V2. So, we will have 2E0 is equal to current flowing from this end and current flowing from this end. Yeah, so that will tell us the current through R1 or R. So this is R, let us say, and the current is, let us say, let's call it I 4, which is going like this one. This is R, and we know that the potential difference is, here we have 2E, so V equal to 2E and V equal to 0. So the equation will be equal to stiffness matrix for the element will be 1 over R, right, 1 minus 1 minus 1 1, stiffness matrix multiplied by, you know that the displacement. So displacement here is equivalent to the voltage. So you have 2E and 0, and that will be equal to current here, right. So that will be if it is going like this, if it is flowing like this, let us say flowing like this one. So then we know that at this end this is coming, so this will be positive, this end it is going outwards will be negative, right. So same, right. So if it is the same I4, so it will be like that. So it should be equal to I4 and minus I4, that we know, right. So okay, so that gives us I4 is equal to 2E multiplied by 1 divided by R. So 2E over R, this 0 multiplied by this one is 0 1, so 2E over R. So I4 equal to 2E over R, that is it. So this is the answer. This is equal to current flowing through R, right. Similarly, similar analysis you can do for the current flowing through 2R, and you have 2R. Similarly, let us call this is I5. So I5, and you have 2E, V equal to 2E here, and V equal to 0 here. So equation will be 1 over 2R and 1 minus 1 minus 1 1, and multiplied by 2E 0 will be equal to I5 minus I5, right. So you know that here anything which is entering the circuit is positive, leaving is negative, hence, but current flows, if it is through, has to flow in the same direction. If the both we are writing I5, those should have the same direction. So I5 and I5 both, but since here going out of the circuit, hence minus term is there, okay. Or what you get is 2E 0, right. So 2E here and divided by 2R, so you get E over R. So, or I5 equal to E over R, hence the which is equal to current flowing through 2R. Okay. So basically we have found out, and this will be from left to right. The previous case, this will be also, sense will be from left to right, right. So this is left to right only. Okay, so we got the values also and the direction also for all the resistances and cells. Okay, so this is how you have to solve. Okay, so we are done with the solutions. Excuse me, I just spotted one mistake. So see here, we calculated I2, so minus 3 E over R minus E over 3R. So 3 times 3, so 9 plus 1 is 10, divided by should be 3R. So I had written by mistake 3, just R, so it will be 3R we have to write here. So I am going to write like this, multiplied by 3, yeah, okay. and everywhere you have to accordingly you have to correct it. Yeah, so this value here I am going to write 23. Okay, so on the next page also let's do correction. So you will be 10e over 3 r multiplied by 3. Okay, so let's write 10e over 3 r. Okay, so okay, so that is all. Yeah, so this should be 10 over 10e over 3r.